Honorable Sokpen, and all the audience here. So I had a pleasure to chair and the host this third session, which basically deals with the policy domains. Three topics. We have three topics on this, which is quite distinct, but at the same time connected. So it's quite interesting. First, we have on the conservation by Dr. Kille Tenzin. Then we have on the timber as a structural material, which I'm pretty sure that there would be lots of triggering factors on that, because we can see from the earlier session, in the morning session, on the two different schools of thought. And we also have Yishio Choden from the DITT on the space technology for Bhutan. So three of them would be speaking on this session. So first, we'll go by the sequence. I'll invite Executive Director, Dr. Kille Tenzin, from the Royal Society for Protection of Nature, RSPN, on the topic saving from extinctions. So as in the introductory sessions in the morning, as I said, Nacharagi Nalut, we have Dr. Kille, who has a rich experience in forest and conservation. He started his career since 1980s in Nilaimbe, and lots of experiences in terms of conservation. And currently he's with the Royal Society for Protection of Nature, and he's also a member for National Environment Commission. So he brings lots of rich experiences in this topic. So I had a pleasure to invite Dr. Kille for the presentation.
Thank you, Pema sir. I think for me personally, this is quite enriching, in terms of people coming from different backgrounds and talking about conservation, talking about circular economic to democracy. It's really interesting. And whatever said and done, I think we must all understand that from whatever background you come from, I think we are all connected. I think this is where, at the bottom line that we must understand, when I speak. And it was also very enriching this morning that, when Dr. Siegel talked about, the series of the extinctions, perhaps the 5 cycle of extinctions, that has actually happened on this earth, and the prediction of extinction for the next 50 years, including ourselves, if you are not careful. Basically my talk will actually complement, what Dr. Singh has actually talked about. So here I'll be talking about the saving from extinction, one of the critically endangered species called white-bellied heron in our country, And before I go into this, I would also like to take you briefly through, who we are. Sorry. I think RSPN, as most of you may already heard, or you already know that, RSPN is a non-governmental organization. It was established in 1987 under the royal command of His Majesty the Fourth King. RSPN was also blessed with the royal patronage of His Majesty the King himself from 1999 to 2012. And currently we are again blessed to have the royal patronage of Her Majesty the Queen of Bhutan. This is our vision and mission as an organization, and this vision and mission was framed in 1987, perhaps, when the organization was established. And our mission was that future generation of Bhutan will live in an environmental sustainable society with a mission to inspire the personal responsibility and the active involvement of people of Bhutan in the conservation of the kingdom's environment through holistic using ecosystem-based solutions. Here to conduct this kind of conservation work, we use this a circle to represent, our conservation journey. We call it ourselves a conservation mandala, basically explaining, how this 4 approaches at the outer circle is being used to implement the conservation activity or the programs of the 10 thematic area in the middle to reach at the overarching goal of the RSPN. Of course, I think the goal is not only for RSPN, but I think it is also for the global community, perhaps I should say that, that environmentally sustainable society. The foray approaches, at this outer circle, such as, this community engagement and development, research and monitoring, species-based conservation, environmental education advocacy has been RSPN strength for the last 15 years. And the 10 thematic areas that you see in the middle are based on the national and international priorities and concern, which is also aligned to support the Sustainable Development Goal of the United Nations. And amongst these 10 thematic areas, the conservation of the white-bellied heron and the black-necked crane has always been, the primary focus of the RSPN. And here, I will be briefly talking about white-bellied heron. As I said earlier, white-bellied heron is critically endangered all over the world. We had this international conference in 2015, and during the international conference, it was confirmed that there are less than 60 individuals all over the world. And Bhutan actually hosts 50% of this global population. Well, as of 2015, Bhutan actually has 28 individuals, and perhaps 18 individuals in Myanmar and 6 in India. It's very sad to know that it's already being extinct from Nepal and Bangladesh. And currently, Bhutan hosts 25 individuals with 5 juveniles. And very recently, I think you must have also seen in the Facebook and Twitter and as well in the newspaper that one individual has made an accident and died. This is to show that the global distribution of the habitat range in 1930s. You would actually see that how white-bellied heron distribution range is widely pronounced in 1930s, and eventually in 2015, the habitat actually has really shrunk in a very thin line, as projected in the habitat range countries, and that are because it is not nice, from the conservation point of view, especially for me to say that the decrease in the habitat range is because of the hydropower plants. But the fact is that hydropower plant construction has been going on in all these range countries, and that has actually eventually led to the decrease in fish population in the river. And when the hydropower comes in, a lot of people comes in, and white-bellied heron is one bird that cannot actually tolerate the disturbance of the people. And other disturbances are combined with natural disturbance like predators, forest fire. In Bhutan, white-bellied heron is found along Puna Sangchu in Mochu and Puna Sangchu, then also in Mangdichu and some part in Kurichu. And you would actually see that, I think these are self-explanatory for you, that the dots in the map actually means that, that these are the observation points, for us, and these are being laid, these observation points for the last 15 years, and we are still, monitoring these birds, very aggressively. And this is just to show that, the dynamics, the population dynamics of the white-bellied heron in Bhutan, you actually see that through, RSPN's rigorous kind of effort, conservation effort, we were actually able to maintain plus 3, plus and minus 3 up and down. And as I said earlier, we currently have 25 individuals, at the. One of the very major endorsement that came out from the international conference in 2015 was the need for captive breeding facility center. RSPN has been negotiating very aggressively again with the hydropower plant companies, for the last many years. And in 2016, with the help of some of our parliamentary members, ex-parliamentary members here, I think they are very much aware. They were also being part of, this negotiation, with the hydropower plant companies, and we were actually able to get this, the approval from the hydropower plant companies, and the construction is currently going on, and we expect to finish this construction by end of this year. The chick, I think. Anyway, the chick that I have shown here is to show you that the captive breeding piloting was done in 2011, and this was successfully done, through artificial incubations, and we have successfully released in the wild. And currently, RSPN is carrying very aggressive program on white-bellied heron conservation through community incentive-based approach, consultation with the governments and hydropower plant companies, planning, meeting with local governments and local communities, collaborative field assessment and activity implementations, education awareness, then regular monitoring and evaluation. Then on the species based conservation programs are these are the few the comprehensive the activity that RSPN was doing and will also keep on doing. The comprehensive survey on white-bellied heron and hunting of their nest along these habitat areas. Satellite telemetric tagging on post-fledged juveniles to study their behavior and also their life history, and habitat foraging and nesting, evaluation of fish population above and below hydropower plants, development of strategies for collection of eggs and juveniles, construction of captive breeding, as I said earlier, and also to establish funds to support the ex situ and in situ conservation. Okay, perhaps the question we have to ask ourselves is, why white-bellied heron? Why white-bellied heron? As I said earlier, white-bellied heron is important not because it's critically endangered, but such type of species are important because they represent our ecosystem. A healthy ecosystem, in the rivers, and the healthy ecosystem, of its surroundings, and because of that, that reasons, of course, there are other reasons, which probably I may, I think, interact with you, when you ask questions. I think for me, what we also have to be mindful, as this morning the Dr. Sige rightly said, that what we have to be mindful is that conservation is not only about saving this kind of a flagship species, tigers, the forest, and of course we also talked about plastics in the oceans. I think eventually it is all about saving ourselves on this planet. And that is very important. And that is why, currently, the global community all over is putting a lot of, important emphasis on conservation. As I said, we are also putting a lot of in situ conservation efforts. We also have instituted this International Technical Advisory Committee on white-bellied heron in 2016. And the committee comes from all over the world, as you see in the slides. And their main role is not only to technically backstop on the conservation of the white-bellied heron, but also raise funds. Because at the end of the day, if we have no money, we cannot do anything. And this is just to briefly show the conservation partners that RSPN has been working with, for the last 25 years. Not necessarily all of these conservation partners put emphasis on the conservation of the white-bellied heron, but there are a few, such as MABA Foundations, International Crane Foundations, Bhutan Trust Fund, and now even Bhutan for Life, for that matter, and of course WWF in Bhutan as well. Thank you. Visit us at this site. We have all the information there, what we do, what we have done, and what we will be doing for the next 20 years from now. Thank you so much.
Thank you, Doctor. I would like to request you to take this stage now. Through the presentations, I'm pretty sure that we have lots of questions in our mind. We have the endangered species, roughly which the total population counts to 60, and from there, about 40% of that individual counts are here in Bhutan. At the same time, if you see the habitat, it's all located through our hydropower projects basin. It's Punata Chu, it's Mangde Chu, it's the Kuri Chu, except to Pipsu Wildlife Sanctuary, I believe. So therefore, I'm pretty sure that our audience will have lots of questions, so which we will take it after all the presentation is done. So we'll have a sequence of presentation for the to complete first, and then we'll take the stock of questions after the question at the end. So therefore, I would like to request all the audience here, if you have any questions, to jot down, and then we'll open up the floor after the end of presentation from all the sides. So the second presenter, we have Mr. Theong Nyudup. He's a senior lecturer with the College of Science and Technology. He will deal with he will present on the timber as a structural matter for sustainable society. So it is closely linked with the debate that we had in the morning session in terms of the two schools of thoughts on the use of the resources. So probably the presentation from Mr. Theong Nyudup would be focusing on the use of timber as a structural materials and how it will be contributed in terms of the development and as well as on the sustainable approach. So I would like to request Mr. Theong Nyudup to present his paper.
I recall we had a some very passionate remarks being raised in the morning regarding the use and conservation and consumption of timber. And I suspect the same level of passionate interaction, because I'm also going to I'm going to make a case for timber as the material for the 21st century. So this is my topic. So this is my topic, and I'm going to make a case for timber as the material for the 21st century. And probably some of you might be feeling a bit sleepy, so I guess how many of you might have looked up in the evening sky on a clear winter night? So if you have done that, you might recognize what this image is, right? So this is the Milky Way, right, our galaxy. And the reason why I show it is, if you are making any guesses, there are about 400 billion stars in our Milky Way. Just keep that number in your mind. And there are 3 trillion trees on Earth. Right? So it's almost about 1,000 times more trees on our Earth than we have stars in our Milky Way. And of those 3 trillion trees, as per the recent official document released by the Ministry of Forest, Agriculture and Forest, of that 0.8 billion trees are in Bhutan. Right? But then we need to qualify what do we mean by tree. Right? So I think the technical definition that they use to define tree is any tree, if you measure the diameter of the tree at a breast height level, and if the tree diameter is about more than 4 to 5 inches, then you qualify that as a tree. So any shrubs are not considered as tree. So this just to set the tone for my talk. Right? So we have more trees on Earth than we have stars in our Milky Way. Now, why tree, right? So people might be wondering why we talk about timber, and then we talk about the population, right? So by 2050, our world population is going to touch 10 billion people, 3 billion people more than what we have right now, and each one of those individuals will need a shelter. So by some estimates, by 2050, 100,000 homes needs to be built a day. Right? So then what are we going to use to make those homes? So we already are being told about the need to limit our global temperature rise within 1.5 to 2 degrees centigrade. Right? And what are the main causes of those global warming and climate change? So the building industry is a big player in the overall, one of the biggest reasons why we're not able to really take control of our carbon dioxide emission. So what is the ecological footprint of a building industry? So just to show it briefly, it is responsible for almost 40% of all these different categories, right? 40% of global resource consumption, 40% of global energy consumption, 40% of greenhouse gas emission, and 40% of solid waste generation comes from the building sector alone. And why is this? Because of the use of the conventional construction material of of steel and concrete and other plastic materials. So it's a choice we have to make now, right? Do we save the planet and forget providing shelter, or do we provide shelter and then at the risk of putting our own future in danger, right? So it's more like a Sophie's choice, right? Either way, you are damned. So then what is the solution here, right? So the solution is, luckily or fortunately, timber does offer a solution here, right? So I'm going to make the case as to how timber is going to make a solution here. So why timber, you might wonder. So I'll put that under 4 categories, right? So being an engineer, and of course, safety of the occupants of a building or a bridge is of utmost importance. So I have to make the structural case for timber, right? Why is it better than steel and concrete? Worried about the energy use, I have to also make a case for energy consumption. We have to also make the case for the environment. And of course, cost, right? Ultimately, everything is about cost. So how much is it going to cost us? So I'll make 4 cases, just run through them briefly. So just ignore everything that's on the slide, just focus on the numbers here, because there are too many. So just focus on the numbers. So the bigger the number, it's better, right? So keep it at that right now. So if you see a bigger number, then it's better. So at first glance, it might seem that timber, okay, if you take spruce for example, is the least favorable of the 3, right, the conventional materials, because it has got the least number here. But that is for the general public, right? But for an engineer, and especially a structural engineer who is involved in designing bridges and buildings, this is not very important. The second segment of the numbers are very important to us. So when you go there, right, and it's a different scenario altogether. So you see wood almost as equal as steel, but as you go further right, the 2 conventional material cannot compete with wood in terms of efficiency. The only comparable material that we have at the moment are carbon composites, right? But these are very high energy intensive artificial material that is produced by the industry. And you can see they have some comparable values as comparable to that offered by timber. So from here, what we get is there's a high premium on being light, right? So what is the secret to that? Because wood is light, right? It will float on water, right? So the density is 0.5, so it's half as heavy as water. So there's a high premium on being light. The second case, the energy case, right? So forget all the other materials, just focus on the composites, right? Which has almost the same level of efficiency as wood. But then what would be the amount of energy you would need to invest to make a segment, say a building of carbon composites? You can see so if you need 1 unit of energy to make something out of steel, you only need about 2% of the energy to make something out of wood. You would need 17 times more energy input to make that segment out of carbon composite. So that's the energy case for wood. So what pays off eventually is not carbon fibers, it is holes, right? Because holes are very cheap, and then they do not need money, or like, who needs money to pay for empty space, right? So it's quite cheap. So thus nature invented wood. Right? So holes it is, right? So if you look at a timber properly, it's almost everything is holes inside, right? So this is a Douglas fir, right? You dive in deeper to look at it much more closely. Then you begin to see all the holes that makes up the internal structure of a wood, right? So it's holes everywhere, right? Cavities through which waters and nutrients flow up and down. So all of you might know this very famous person, right? Muhammad Ali. So a famous phrase was assigned to him, right? He's popularly known as the person who flies like a butterfly and stings like a bee. So I call timber the Muhammad Ali of construction materials. Right? So because it's very light but very efficient, right? Very effective. Right? So if anything you can take out from this conference, maybe if you remember this, I think I've done my job, almost halfway done my job. So moving on. So the environmental case, right? So this is the crux of the whole debate or discussion we're having, right? So you go to concrete steel. So steel, some might say is 5%, some might say 3%, but I've taken the much conservative value of 3%. So 3% steel is responsible for 3% of carbon dioxide greenhouse gas emission in the world. Concrete about 5 to 8%. What does wood do? Right? A cubic meter of wood, say a chunk of furniture in your house, would capture in almost a ton of carbon dioxide. So it locks in carbon dioxide, it sequesters carbon dioxide, it will not let it go out. Rather, in the process, a cubic meter of wood would release about 550 kgs of oxygen. Right? So that's how we survive. And just to put that in perspective, so if you fly, for example, right, frequent flyers might be quite conscious about the environmental impact of their habit. So it's about 1.6% airlines, shipping, all these logistics, widely used building material is about 5%. It's responsible for 5% of the carbon dioxide emission globally. So that's the environmental case for timber. There are some other data, but because in the interest of time, I might skip that. The sustainability case, right? So some species, I think they're very fast-growing species, so people from the forest might be able to give more information. So timber can take just about anything between 20 to 25 years to grow from a sapling stage to a full-grown mature timber. Right? So it has been found out that enough wood for the 7-story building is grown every 15 minutes in the US and Canadian forest. Right? And think of the replenishment cycle of the raw materials needed for steel and concrete, right? Limestone and iron, they recycle under geological timeline, right? It takes thousands of years for the raw materials to recycle. And finally, the money case, right? The economical case. So researchers all around the world have found out that some of the research it's not really all around the world, but some researchers conducted in Australia, in Canada, in Europe found out that it's 20% cheaper, 30% quicker, 4 times lighter. So lighter the material is, there's the ease of handling and erecting your structure much faster, and better safety outcomes. And then you also get a bonus, right? All of this packaged in the natural warmth and comfort from a wood, right? So an architect once said he has never seen his client go and hug a column made of concrete and steel, but I've seen people hugging and feeling the timber panels or woods in the building that he has designed, right? So you get that feel of that warmth and comfort if you have buildings made out of timber. So just to show you some pictures of where the wood technology how the wood technology has evolved. So this is the epitome of, right, the epitome of timber technology, right? More than 1700 years old, still standing, withstood all hurricanes and earthquakes, made out of timber in Japan, the pagodas in Japan. This is a timber building recently finished, constructed in Norway, 80 meters tall. Right? And what's the future? This is called the Oakwood Tower in London. It's going to be about 80 stories, 340 meters tall, purely made out of timber. Right? So this is the past, the present, and the future of timber. So what's happening here in our country? Right? So it's not that we are alien to this timber, the technologies and practices linked to timber. Right? We have a pool of knowledge accumulated over ages of our association with timber. Right? So there's a very simple timber bridge, a balsam bridge built in Punakha, bamboo timber composites. Right? So very elegant, very beautiful structures. But what's happening at the moment is, with this overdrive or the advent of the so-called modern construction materials of timber, of steel and concrete, people are using these materials much. There's a decline in the use of this material, and the danger is in the long run we might even lose the technical know-how and indigenous practices that we are used to. But saying that doesn't mean that there's no problem with timber. Right? Timber does have its own weaknesses. Right? So what are the challenges? Right? So, but then I'm of the opinion that if you do nothing because of the challenges, then it might be a case of missing the forest for the trees. Right? So just for saving a tree, you're losing the larger picture then, right? So, but there are challenges, but then there are ways to also overcome these challenges, right? So the first challenge, of course, so every time I talk about timber, be it my students or anybody I know, they say, you're going to cut down all the trees, right? So we need to save the forest. There's a mandate to protect, keep at least 60% of coverage on the forest. So are you going to promote, advocate cutting down all the trees? Right? So it's important that we don't miss the forest for the trees, and a right balance has to be struck between consumption and conservation. Right? So how do you do that now, right? So that's where the ecologists or the conservationists should come in, right? So the idea that's going around in the world right now is just as we grow our food, there is a potential to grow our homes, right? So because timber we can harvest them within a cycle of 20-year period. So can we not also think of growing our homes? Right? So maybe it might take too much time, but so how do you do that then, right? So there's a very groundbreaking research done by this ecologist, Professor Susan Simrad. So what she discovered was the trees actually communicate, right? So in a forest wooded area, the trees in fact really communicate with each other. So she called this wood wide web, right? So just as we had World Wide Web, so she called this the natural internet, nature's internet. So the key point here that we can take is, so there are some important trees in a forest, right? So if we make sure that we don't chop down those trees, what she called as the hub tree or the mother tree, because they are key to the survival or the how well a forest ecosystem thrives, right? So long as we can identify those mother trees, we can cut down trees, but then make sure that the mother trees are protected. So that's nature, she called it wood wide web. So what lesson can we learn from there, right? So just as I said, so conserve the herb tree, right? Just to skip through the slides in the interest of time. Fire is another problem, right? So everybody thinks of timber as being very vulnerable to fire, but it is not the case that steel and concrete are any better, right? In fact, the reason why the Twin Tower collapsed is not because of the impact of the aeroplane, but it's because of the ensuing fire that has melted the steel, right? So in fact, steel is much, much more vulnerable to fire than timber. Right? Have you ever seen a block of timber just catch fire when you strike a match, right? So you need some ignition temperature. And also if it catches fire, then what wood does is it will form a layer of char, right? That black thing, and that char insulates the inner core of the timber. Right? So in the design, if you have taken care of that, so I'm going to provide some additional thickness to just let the char form, your core skeleton is still intact. Right? So whereas that's not going to be possible with steel. Steel is going to melt and just flow like a liquid. And same with the case with concrete, right? Concrete is going to spall and crack and crush. So these are the information I have. Okay, durability again, right? So if you have, so the problem here is the moisture, right? So long as you have treated, seasoned your timber well, right, timber structures are as durable as concrete, and in some cases even better than concrete and steel structures. So this, the major problem with timber in our case is that you cannot really rely on the quality of timber, right? So we take a piece of steel and we know that any point on the steel has the same properties, but that's not possible with timber because that's why we call it anisotropic, right? Maybe stronger on the tail and weaker on the head. So that is the biggest challenge with us. So how can we rely on a member that has got a lot of variation in the quality, even in the same single specimen, right? And that's where the engineered wood products kick in, right? So there are ways to address this problem, right? So the biggest benefit of this engineered wood timber product are that we get the benefit of heavy timber without having to cut down any large trees. Right? So maybe we can discuss that in the Q&A session. So what is the scope in Bhutan then, right? So in the morning there was some discussion about whether it's 71% or 84%, but the official document I think is 71%, right? So, and then of the 71% coverage, we have 0.8 billion trees. So these are the forest proportion by tree, right? So by species. So 50% broadleaf, 20% coniferous. So what I've done is I've calculated the volume of timber that is in excess of the 60% mandated by the Constitution, right? So how much cubic meter of timber are there in the additional 11% of forest in our country, and that also from the seven species, seven most abundant species. So then what I did is I did a design for a 4-story structure, right, having 8 units, so a typical building in a town, right? So that's quite common, a representative building. And as per my estimation, we need about 45,000 such buildings to provide shelter to the number of people that we are going to have in 2050. Right? So that's based on population growth and the average household size as per the NSB data. So I found out that we need additional 45,000 4-story buildings, okay, having 8 units. So then I calculated how much volume of concrete, how much volume of steel, and how much volume of timber would be needed to make those structures. So it turns out that we do in fact have more timber than what would be required to make those structures. If even we have to make it entirely out of timber, right? But that is on paper, right? All the timber are in the jungle right now, right? It's in the forest. So that's another challenge. But theoretically, it does seem that we would have enough timber just by touching the additional 11% that's in excess of the 60% mandated by the Constitution. So what does this say then? Right? So what does this tell us? So in the process, right, if we make all the structure out of timber, we would be sequestering. That means we would be capturing about 22 million metric ton of carbon dioxide. That is equivalent to taking off, how many million is that now? So 4 million, 73, yeah, so anyway, that many number of cars off the road for a year, right? Average passenger car is estimated to emit about 4.6 tons of carbon dioxide in a year. And if you can stop that many volume of carbon dioxide going in the air, it's equivalent to having taken off this many number of vehicles from the road for a year. Right? So that is the sustainability case for the timber. But as I told you, it's all on paper and theory. A lot of things needs to be done. So I just propose here 5. So we need to plant a seed now, right? So that we can reap the benefit in 2050. And we need to plant the seed now, and the seed needs manure, right? It needs fertilizers. And I propose 5 fertilizers. So the first one is sustainable forest management practices. Right? We cannot have a thriving timber industry without a thriving forest, right? So we need to, as we say in Dzongkha, right, better to milk the red cow than kill it at once, right? So how can we do that? Right? So that's where the forest conservation people and ecologists should come in and start advocating and promoting sustainable forest management practices. Second one is revamping the forest industry, the timber industry. It's ridden with wastages right now, right? You buy 10 CFT of timber and you can only use 5 CFT in your building, right? It's full of wastages. And there's a lot we need to do in sourcing and in, maybe I'll run down quickly. Engineering standards, very important. The only document that I found so far was a document made by an Indian consultant in 1984, right? After that, there was no document on technical standards related to timber construction. We need manpower, of course, to know the technology. And then, of course, research and development in trying to see how we can further promote this. So finally, I'll skip all this. So under the leadership of our visionary monarchs, right, we have a very noble vision of having an ecologically balanced economic growth. So how can we achieve that, right? How do we honor our vision, right? So what will it take to fulfill this vision? Right? So it's time, I think we need to rethink the scale, the design, and the building blocks with which we make our infrastructure. So in that, I think we can draw some inspiration from 5 very critical stages in the life of Gautama the Buddha, right? Buddha was born under a tree. At the age of 5, he had his first taste of meditation under a tree. He obtained enlightenment under the tree. He preached his first sermon under a tree, and of course passed away under a tree. Right? So would it not make sense for us as a Jainish people also to live in a building made out of tree? Right? So, from all the reading and research that I've done so far, I have to admit I still do not know the name of this very wonderful tree we have in our campus. I asked all my colleagues, senior members, they also do not know. So maybe some of you here might be able to tell me what is the species or name of the tree here. And I would like to close by a proverb, a Chinese proverb. So it said that the best time to grow a tree was 50 years ago, and the next best time is today. So thank you.
Thank you, Mr. Theong. I would like to request to take the stage. Now, through the presentations, I'm pretty sure that the empirical points has been presented from all the angles, like in terms of efficiency, energy, environment, and other cases. So, but on the other side, as a layman, as a common people, we understand that on the practical issues, there are so many things we have questions in our mind. Starting from the timber reserve, some paper says that we have more of timber reserve. Some paper says we have a timber shortage, so we even have to import from the other countries. So many questions must be coming. So I request all the audience to note down the questions. I too have many questions on the same topic. So we'll be dealing at the end of the presentation. So next, I would like to request Yishe Choden, if she's here. So the Yishe is currently an engineer working with DITT, and she will be presenting her paper on the space technology. It's a very new topic, and probably presented by one of the youngest speakers. And we are very excited to learn about. And in fact, myself also, I'm a very non-technical person, so therefore, I'm very eager to listen on the space technology and the area that we have to explore, and especially to be presented by one of the youngest speakers. So we will be looking forward to hear from you. Thank you.
A very good afternoon. On a serious note, my name is Yishe Choden, and I'm currently working as a space engineer with the Division of Telecom and Space, which is a very new division, and we just have about 5 or 6 people in this division specifically working for space technology in Bhutan. Now, before starting my presentation, I would like to have a show of hands. Who in this room knows about space technology? Or have heard about it? Or have the slightest idea about what space technology is? Can I see the hands? Okay. That's like 50% of the audience here. So I'm very happy because 50% knows about space technology, and also very happy because 50% doesn't know about space technology. So it really makes my presentation here something valuable, because I will be adding new information to the 50% who don't have any idea about space technology. Okay. So, just to give you a brief background about how Bhutan started our space technology and the space program that is very young, I would like to direct you to my first slide, which is the portrait of His Majesty the King. So the space program of Bhutan began with the vision of His Majesty the King to raise awareness and generate interest in space science and technology in order to improve the lives of the Bhutanese people. So the end goal of our space program is to make the lives of our Bhutanese people better in terms of socioeconomic prospects. The reason why we started space technology in Bhutan, even for me as an individual, although I may be young and born in this 21st century, I never thought that Bhutan will ever have space technology. The space technology always seemed like something which only the Westerners do, or somewhere, which happens like somewhere really far, and it's something which only we can see in sci-fi movies or something like that. So I never thought that I would be one day a person working in the space program of Bhutan. So all of this is possible because His Majesty the King has a very profound and long-term vision for space in Bhutan. And this, I think, you will know better by the end of my presentation. So please keep that in mind. Now, I became a team member of this satellite project. And this is the first satellite of Bhutan, although it is a 10 centimeter cube in size. Yes, it's very small, and sometimes we joke and say that it is the cute sat. actually it's supposed to be a CubeSat because it's in the shape of a cube. But this is nevertheless, although it may be a very small one, it became the first satellite of Bhutan, and we launched it last year in June using one of the rockets of the SpaceX company by Elon Musk. And we first launched it to the International Space Station, which, if you don't know, it is that space station which is hovering over Earth or orbiting around Earth even now, and there are usually 6 astronauts living in the International Space Station at any given time. So the mass of our satellite was 1.2 kilograms, and some of the missions that we put on our satellite were camera, APRS, digipeater, store and forward. All of this sounds very alien, I know, but basically we were just experimenting because this is our first satellite, and we just wanted to get a feel of what it's like to actually make a satellite and what it's like to actually have a space program. So we launched our satellite last year, and as of now, we still have it in orbit. So every day we can have our satellite passing over Bhutan 3 or 4 times, and we have so we have a ground station in Bhutan as well as in Japan, because this was developed in Japan, and we have a ground station there as well. So this whole project was a part of the overall Birds 2 project. It is a joint multi-nations project which is hosted at the University Kyushu Institute of Technology in Japan. So as part of the second project, Bhutan, Philippines, and Malaysia, we designed, so this is our satellite team. We designed one satellite, but then at the end we made 3 identical satellites from the same design. So that's how we became part of the project. And each of us, Bhutan, Malaysia, and Philippines, we have our own satellite names. For Bhutan, it's Bhutan 1. For Philippines, it's called Maya 1. And for Malaysia, it's called UITM Sat 1. These are a few pictures of us in action. Then for Bhutan 1, we have the ground station, as I mentioned, at DITT office in Thimphu. So we mounted a antenna on the rooftop of our building, and we also have a room where we have some computers which runs the softwares to track our satellite. Now, zooming out from this, now let's look at the global space economy, how big it really is. Although we may have been out of this picture for a really long time, there is a whole booming economy for space out there. So the total global space economy values at $344.5 billion as of 2016. And over the last couple of years, it has been growing at an exponential speed. Earlier, one of the speakers mentioned that we are now in the Industrial Revolution 4.0, and in line with that, even for space, we are at the revolution of Space 4.0. So a lot of this economy is, the majority part of this economy is occupied by the US government, followed by Russia and so many other big companies. But now in the Space 4.0 revolution period, we are seeing an exponential growth of new players in the space industry. For example, a very good example is Bhutan. Nobody would have thought that Bhutan would become one of the new players in the space industry, but because we are in this era of Space 4.0, where a lot of technology innovation is happening and everything is growing at a very fast pace, even a very small country like Bhutan can become a member of the space economy. Now, this whole slide, I would like to hashtag it, did you know, okay? Because there are going to be a lot of information which some people may know here, but a lot of you may not know as well. So I would like to hashtag it, did you know? And I would like to explain this under the large topic of why space? Why do we want space technology? So the first one is agriculture. Did you know that remote sensing satellites provide key data for monitoring soil, snow cover, drought, crop development, and yield that can inform the farmers for improving their agriculture practices? Okay, second one, global health. Did you know that remote sensing technologies can be applied to study the epidemiology of infectious diseases, monitor disease patterns, understand environmental triggers for spread of diseases, predict risk areas, and define regions that require disease control planning? Computer and telecommunications technologies, including satellite communications, enable sharing of health and medical expertise. That's where telemedicine comes into play. Did you know that remotely sensed data have enhanced scientific understanding of water cycles, air quality, forests, and other aspects of the natural environment? Did you know that Earth observation from space is a cost-effective way of obtaining unbiased and essential data on the physical world? Decision makers can use this information to understand trends, evaluate needs, and create sustainable development policies and programs in the best interests of all populations. So likewise, we have a lot of benefits from space which we may not have known about. And also for disasters, education, human settlement, research and development, transportation, communication, in all these areas, space can play a big role. Space for the Sustainable Development Goals, not only does this benefits expand across all of our lives, but also across all the Sustainable Development Goals, especially for areas like gender equality, clean water and sanitation. In all these development goals, space has a lot of potential. Now let's zoom back to our very own small country. In Bhutan, where can space be applied? Is space really useful for us? So when I was doing my master's course in Japan, I had the privilege of carrying out a 4-month internship at the United Nations Office for Outer Space Affairs. And my particular interest was in ensuring in understanding how to ensure the sustainability of space activities in Bhutan. Because as I've mentioned, there are a lot of new players in the space industry, but we also see a lot of those new players remaining stagnant, or their space program does not take off after the first project. So that was my biggest concern. And in doing so, I tried to scan the 12th five-year plan of our government. Because I really wanted to know where in Bhutan can we apply space technology. Because if there is the need for space technology, then definitely the space technology can be sustainable in the country. So if you look at the map of Bhutan, I have identified about 21 different themes where space can be applied in Bhutan during my internship. And they span across 14 national key result areas, 64 key performance indicators, and 21 themes. So they can be applied in areas like education, air quality, climate and weather, water management, preserving our cultural heritage sites, in assessing the potential or efficiency of the hydropower projects. So space technology for Bhutan looks very promising. For example, if you zoom in on the agriculture theme per se, especially for the NKRA 8, water, food, and nutrition security, we have 2 particular key performance indicators that can be directly affected or enhanced using space science and technology. So this is basically to measure the production of rice and maize crops in order to assess our self-sufficiency. So in this, we can use the remote sensing satellite data to track the growth of these 2 crops and try to estimate or forecast their yield prior to their season. So if we understand their growth patterns, then we will be clearly able to identify how much maize we are going to produce this year. And according to that, this data, which is very accurate, can be used by the policymakers, the agro-based industries, and they can use it to make informed decisions, like how much rice we should export or at what rate we should export and how much we should import or when is the good time to import and all these important decisions. So last but not the least, if you have a mobile phone with internet connection, please log on to this website and I have a short survey for audience participation. Or you can scan this QR code if you're near enough. So if the survey is opening properly, I have just formulated about 3 questions. It's related to space technology for Bhutan, but it's very basic questions, so you should be able to complete it in 1 minute. Should I read out the website for you? It's www.surveymonkey.com. surveymonkey.com /r www.surveymonkey.com /r/ then capital PZ, capital P, capital Z, 5, capital T, capital N, capital X, and 7. Sorry, everybody, I meant this to be a fun experience. Did someone finish the survey? How was it? Very easy, right? Very difficult. So basically, I was just asking 3 questions. The first one is, what services, name 3 services around you that uses space technology. So anyone wants to say their survey out loud? Name 3 services around you that you use every day that comes from space, basically. Mobile, GPS, okay, one more. Internet service, okay. Mobile, GPS, internet service. And the next question was, should we buy satellite data from other providers or should we as a country develop our own satellite? Buy? Who wants to buy? Who has so much money? No, that's why we have the survey. I just want to get your idea right now. So should we buy? Or should we build? Okay, we should build, yes. And that's good work for me. And the last question is, do you think I can build a satellite? Or Bhutanese people can build satellites? Please give me some more motivation. Anyway, thank you so much for being very responsive and motivating. Now I feel more encouraged to build bigger satellites with more functions in the future. So with this, I come to my last slide, and I would like to leave you with this quote, which says, "There's something about space that touches even people who are not interested in science." So just think about that, and thank you very much.
Thank you, Ishi. So with this, we came to the end of the presentation phase, and now I would like to request all the 3 panelists to take the stage of us. Thank you, panelists. So 1 round of applause for them. So now, in the interest of time, I would like to open up the floor. First, to begin, I would like to ask 1 question each to all the panel members. You can take note of the questions and then answer it after I finish all the questions. Then we'll open up the floor for the audience to put up the questions. So the first question to Dr. Kinlela, from your presentation as well as from many of the research papers that we read, we see that many of the habitat in Bhutan for the heron is located in the hydropower places in Bebola. Where do you find the thing, whether it is in terms of opportunities or in terms of challenges? When you see if you read the papers, it is more of the challenges. But at the same time, today is an opportunity to hear from your expert view what are the opportunities as well as besides the challenges. So this is my question to Dr. Kilela. So how do you see the habitats of the herons located in all the water basins that have hydropower construction sites? So where do you see the things? And second question to Mr. Thong on the timber. Again, that's very critical thing. On the one hand, we see lots of papers which says we have a huge timber reserve. If I get back to the Dr. Finso's paper on the same case, he have presented empirically that there are enough timber reserves in our country which we can harvest sustainably to meet the timber demand. But on the other hand, as we all know, now every construction, be it in the urban or in the rural places, we prefer concrete over timber. So now my questions to the expert would be, where do you see the hurdles? Is it a policy, or is it the awareness of the people, or is it the misinformation that now we have a timber shortages? We don't have. If you see the Dr. Pinso's article on the Quinsel, he says he have given enough evidence to show that we have enough timber reserves. We hardly use 4% from the annual increment. He says that the allowable, there's a term which we can use the certain reserves for the timber, which is about 1.2 million cubic meter thing, but we hardly use about 0.5. So which means that there are enough reserves in our country which we can sustainably harvest. But at the same time, on the other hand, we see the papers, especially the Bhutanese in 2012, where NRDCL have said that we have a timber shortage and we have to even exploring the ways and means to import from India and other neighboring countries. So I would like to hear your expert views on this. And on the third issue, on the space technology, as a common man, who do not have much knowledge on the thing, where do we see our future in terms of using space technology like telecommunication services, or it could be in agriculture, as you said, why space? And also, if you browse, you can see that we pay huge. BBS pays almost 4.5 million in a year, and Department of Hydrology pays about 1.2 million to different thing who provided the thing. And similarly, we have other who uses the services from the outside stations. Where do we see our future, at least at this moment? So these are the three things that we would like to hear, and then we will open up the floor. First, I would like to start with Dr. Kile. Thank you. Yes, please.
Les, thank you so much, Pema sir. I think basically your question, you're asking about the synergy, and the compromise that hydropower plants and conservation, because if you look at the things that are happening in the hydropower plants and also from the conservation point of view, it doesn't actually matches, So I think that is the point. When I joined RSPN in 2015, going through this article of sessions, it was explicitly mentioned that as an NGO, NGO role is one of the role is to be a watchdog to the government's effort. So my stand on this was another way. Today, in 21st century, if we conflict each other, when the teamwork is required on any matter, it doesn't work. So what we actually did was we negotiated with the hydropower plants, very subtly and very tactically, of course, because when you talk about money, it's not so easy as we think. So finally, as I said earlier, we were able to get, a worth of around $700,000 to have these captive breeding constructions. So these are the few of the modalities, that we have applied, and for me, this watchdog concept, doesn't work, and in today's world. I think eventually, since everything is connected to everything else, as I said earlier, I think we perhaps need to connect ourselves because everything is connected. None of the things are isolated. None of the things are, lives very inclusive. I think we are dependent. We are connected. So from that point of view, I think it is not good to conflict. Even though when you carry out your own work, it seems that the conflict seems to be there, but it shouldn't work that way, Mila. So we need to work together, and that's how because especially today's world, I think in the morning, many of these speakers have presented the problems, especially from the conservation front, and because of that, and also from the pollution sides, and for that matter, the climate change. Again, it's whether people believe or not. I think climate change is real. So if we are to address these common issues, then I think we need to come together. Because conservation is all about teamwork. It's all about team effort. Thank you so much.
So I see about 3 different elements in your question, but hopefully I'll be able to capture all of those in my answer. With regards to the discrepancy in the actual figure of the forest coverage, I think it's probably because of the way in which the doctor you mentioned and the Department of Forest might have used to define what forest is for them, right? So even in the morning, someone has raised a point that the official FAO's definition of forest is of a tree, a plant of a height of certain height, having a certain diameter at breast height level. So that is the definition the Department of Forest has taken to count the number of trees, I think. I haven't yet read the doctor's paper, but probably he might have also considered shrubs and even, bushes as forest coverage. So that could be the reason for the discrepancy. With regards to why we are not really using it, right? The analogy I can give is there's a gem in the ocean, right? So we also have a gem in the forest, but then we need the boat and the drivers and the gears and the equipments to really go down deep into the ocean to extract the gem. So something similar to us here, right? The forests are there in the wilderness. So unless we have the infrastructure put in, right, we may not really be able to capitalize on this, the potential of the resource. The other thing that I would like to add here is, of course, I also touched about the need for infrastructure and also particularly the need to revamp our timber industry. The other thing that where we could have a scope of not really having a big impact on the forest coverage is the use of engineered wood products. Right? A very simple example I can give here is the rubber wood furnitures that we have in our offices. Right? So these tables and chairs are made out of wood that were in fact wasted. Right? All they did was put in a new technology called finger jointing, and then out of all the pieces that would have been otherwise thrown away, are assembled together to make a bigger piece of a component that can be used as a table. Like similarly, so there are a lot of technologies and research has been conducted all over the world to produce engineered wood products. And the biggest advantage of that is we can have big timber elements without the need of big trees. So it's not really about going down chopping every tree, every last standing tree. It's also about salvaging the wastages, right? The veneers and the bits and pieces that are thrown about in the industries that we could gather and then use some technology to produce some usable element. So,
So the question was, where do we see our future in using space technology, in which industry per se? So as I've mentioned in my presentation, just by looking at the 12 5-year plan alone, me and my supervisor, we have identified around 64 KPIs in the 12 5-year plan alone where space technology can be used to achieve those KPIs. So by looking at this number, there is a lot of potential for application of space technology in Bhutan, and especially in our development, in achieving our development goals. So the question now really is for all the different stakeholders, because these 64 KPIs span across all the different ministries and about 9 national key result areas. So we need to get together and discuss and consult in which area we should prioritize, because space technology, we need to make some investment of what kind of satellite we want to build and what kind of services we want from the satellite. And we also need to build a lot of capacity in using space technology. So all these different stakeholders, we need to come together and have a discussion about prioritizing the space applications. So that will be my answer. Thank you.
Thank you. Thank you. So now we'll open up the floor.
My question is to Dr. Gila Tenzin, my very good friend. A couple of years ago, I was also involved trying to conserve white-bellied heron. That time, we found out that during a site visit, that there was no fish ladder in the first Punasangchu dam. And the second one was under construction, but they had no plans for fish ladder again. So we were concerned that the Mashare may not be able to migrate upstream of the dams. Therefore, we negotiated, of course, with people from RSPN, with Punasangchu project to provide some funds to breed Mashare ex situ at Gelifu and then have them released upstream of the dam in Punasangchu. Later, I found out that those fish had already been bred and they were of table size, but they were waiting for orders to be released wherever. So were those fish released, and did RSPN notice any kind of effect because of those Punasangchu Project 1 and 2 dams not having fish ladders on the conservation of white-bellied heron? Thank you.
My question goes to Madam student regarding the space technology. To introduce myself, I'm Mr. Sonam Tashi, and currently I'm working in National Center for Hydrology and Meteorology, and I'm working as a weather forecaster. And our center is always using the satellite, which is installed by the JICA. So now my question goes to Madam student regarding that. She have mentioned that Bhutan has launched a nano satellite in June 29, 2018. So I would like to know that whether that satellite is a geostationary satellite or polar orbiting satellite. And according to your document, it is mentioned that the lifespan is 6 to 9 months only. So after finishing that expiry of that lifespan, so what are the plans in the future? So can you elaborate on that one, Madam?
I was really curious about how to identify that mother tree, which almost seems like the mother bee to me. And with that knowledge, what is your plan? Because clearly there seems to be one, a way to conserving the environment and the ecology.
I think this was been over discussed, in many of the forums, whether or not to have a fish, ladder. And if you look at the overall proposal developed by the Hydropower plants company, in the proposals it was clearly reflected that the fish ladder should be installed. But the problem is, when it comes to implementation, in the earlier talk, I forgot to mention about this. The conservation is not just about politics. It's all about saving ourselves, So if that is the common understanding that every one of us here carry, then, I think politics in conservation is the worst. Politics can actually ground, this conservation works, And yes, Dr. Rinzin was right. The fish ladder, I think hydropower plants, of course, hydropower plant, Punasangchu 1 is still going on. They are still building these dams, and I don't know how long they are going to take it. But I think only after, they start to build dams, and that is the time, they will also come up with the fish ladder. And right now, so far, no fish ladder is being actually installed. And on the other note about Mashare, the need for Mashare breeding also started. And lately, we also had this, international conference on Mashare. And during the conference, it was confirmed that, the breeding populations from the, domestication, if you release back to the wild, then there are chances that the genetics, the original, the native genetics of the mushroom will, completely phase out from our river systems. So on that note, of course, the breeding of mushroom is going on, and I have no idea, whether this mushroom raised in the breeding will be released in our river systems. We don't know about that. But then, the endorsement from that international conference is very clear that we should not do that. That will actually, kill, all our, the mushroom in the river. Thank you.
The first one being, what type of satellite is Bhutan 1? So as I mentioned earlier, we developed a CubeSat. So a CubeSat is basically a satellite in the form of a cube, and this is an international standard. So all the CubeSats must be a cube, and then if it is 10 centimeter, it's called 1U. If it is 20 centimeter, we call it 2U, and so on. And the satellite was launched first to the International Space Station, which is at about 450 kilometers above the Earth. So this Earth orbit is called the LEO orbit, low Earth orbit. So it is not a geostationary satellite, because if it were to be a geostationary satellite, it has to be launched at the geostationary orbit, which is at 36,000 kilometers away from Earth. So we launched it at 450 kilometers, which is in LEO orbit, and we call it a LEOsat. Also, the next question about what plans do we have after the end of life of our satellite. So first, we estimated our satellite to be in orbit for about 6 months, but because the degradation, so what happens is when we launch the satellite, because our satellite is very small, so we don't have any active propulsion system in the satellite. So the satellite, once it's in space, although space has almost zero gravity, there is still some gravity. So because of that gravity, the satellite will slowly decrease in altitude, and one fine day it will meet the Earth's atmosphere from space. So when it does that, the satellite is traveling at a speed of 7 kilometers per second. So because of that high speed, and when it comes in contact with the Earth's atmosphere, there will be very strong drag force. So because of that force, the satellite will catch on fire and it will burn, and that will be the end of life of our satellite, sadly. So after the end of our satellite, so the first satellite was just a very experimental project for us and for the whole country. So we are very happy that we were able to develop that small satellite out of scratch, and we were able to launch it. But for the next projects, definitely, because the first project was more like demonstration. So in the next satellite project, I'm sure that everyone is expecting some kind of operational services. So we in the division, we are now in the consultation phase with the relevant stakeholders, and also discussing with relevant prospective satellite development partners. So we will soon be starting, I think, the next project, which will be bigger and which will be offering more services to the country. Thank you.
What I've gathered going through her papers and her documents was, it's usually the oldest tree in that area, because the reason being, the older you are, I think, the more experiences and the more exposure you had to the environment. So she called it that it's the repository of wisdom, right? So that the older tree has a long experience of having been exposed to the natural elements. So she is the repository of the wisdom. So it's normally the oldest or the older trees in that area. But I can allude you to her papers or her talks. So I'm Jewish.
I think you talked about the seed tree selections, the mother trees. I think in silviculture, just like human beings, that the concept works just like us. The more strong we are, so is the tree. So in silviculture system, when we select mother trees, we have certain criteria. Any criteria but if you are interested, please drop me an email. I can actually answer you, because I worked in a research center as a researcher for the last 16 years in forestry. And I'm also a professionally trained forester. So on the other note, I think tree use a lot of water and is detrimental to hydropower plants. I think this kind of statements, I think we need to be very careful because, there are hundreds and hundreds of reports all over the world published in international journals, and in those journals, it clearly says that, glacial lakes are melting, of course. But then, we must understand that glacial lakes discharge, sometimes like little more than 10% of the water to the river systems, and more than 80% of water actually comes from the forests. And if you wanted to know technically how does it work, then probably, I would like to, please drop me an email. I will answer your questions.
My question is to Tsawang. Despite all the advantages that you presented, why is your Muhammad Ali still getting beaten by steel and concrete?
Thank you, Dr. Sige, for provoking me to ask this question to Dr. Kinella. I think all of us are aware about the melting of glacier lakes. Annually, our Earth temperatures increases by 0.4%. With due respect, I have to mention that the pay revision for civil servant and the public servant depends on our sustainability or hydropower is. So therefore, I think we have to save hydropower from extinction. How we can save hydropower from extinction? Thank you.
In engineering, we have something called as inertia, right? So that's the tendency of anything to change. Right? So it's very difficult to fight inertia. You need a lot of effort to do that. And the current inertia is with concrete and steel because these are the conventional materials. And it's not just, of course, here we have hardly even started, but even in developed worlds, I think timber is just about beginning to make some inroads. So a lot of a forum like this is a very wonderful opportunity for people to exchange ideas and get new ideas. And then I think, of course, to be fair, in Bhutan we we are way behind, right? Not just in terms of, I don't know about the forest management practices, but at least insofar as the engineering capabilities and ideas are concerned, the capacity of the contractors and builders to really take it up, even if the design and the technologies are available. So there's a long way for us to go. But I think advocacy and concerted efforts and this platform, this occasion has given us a very wonderful opportunity to advocate and in fact discuss about, at least plant the seed, as I said earlier. So it will grow in the long run, but then we need the manures and the fertilizers. So it's not just the engineers, I think everybody has a role to play in that.
I don't know whether I really understood your questions. Do you mean how to save hydropower from extinction? I have no idea. Maybe I think we should stop, developers to come into the rivers and build hydropower plants. Otherwise, I don't know how to save them from extinctions. I'm sorry. Yeah.
Thank you. I would like to thank all the speakers, 3 speakers, on all the topics that we have presented just now. I believe starting from the conservation, use of the timber, as well as the use of space technology, there are lots of opportunities for us to work together and then explore the avenues in all the angles. So therefore, I think today's session would trigger that, where if the audiences have any things to be follow up, you can keep in touch with the speakers and further discuss on that. Thank you very much for the speakers. And I would like to thank all the audience for your patience. Thank you.